Welcome back. In this lesson, I'm gonna go through a really quick tutorial on how to apply kernel PCA. Earlier, we just do a whole bunch of blobs, kind of not realistic, but I get the actual points and also the reason for kernel PCA out. But what we also want to do is actually just basically apply it to a real-world data. So I'm gonna make use of the familiar data set that we have looked at previously, the iris data set. I know, but I think this will actually highlight what we actually want to do here. The species is not equal to Setosa. Now I'm sure you remember the Setosa as a class on its own is quite well segregated. However, the other two is not so well segregated. So for the purpose of this exercise, we're going to just focus on the versicolor and also virginica. Okay, so seaborn has seaborn low data set. Okay, this one is data set, not data sets. Okay, all right. Now, so the column that we're interested in is the petal length and also the petal width. Okay, and the next thing is we want to store our data into X. Butterfinger. Okay, so the location that we want is all of the rows and just the selected columns. Remember, we want to change the species to number, numerical. Okay, and the versicolor, we want it to be 0, and the virginica, and we're going to change it to 1. Okay, so we'll store this into the temporary. It's equal to the actual species itself, and we're going to map species to number and then store this into Y. Okay, right, now we're going to just apply the kPCA. It's equal to the kernel PCA, and the kernel is equal to RBF, and number of components is equal to 2. Okay, so RBF. All right, that's better. Okay, and X kPCA, we need to fit transform this kPCA fit transform on the X itself. Okay. Now that we've done that, so let's compare. Let's plot this first of all. Linear model. Import the logistic. Just want to contrast this to the logistic regression. Okay, so okay, the next thing is we're just gonna fit them in now. Logistic regression and the COF fit XY. Okay, that went all right. Okay, the next thing now is I'm just gonna copy these codes. These you have seen before many times, and just so that you don't have to watch me type. Now this is the logistic regression, and notice how it actually separates the two classes. As it didn't do a very good job, as you can see. The best way to probably, the best you can is probably cut it this way. But even so, you're still going to have problem that it's going to be misclassified by a big margin, simply because it's not linear in this situation here. So having done that, we're going to do the next thing now is to actually fit the X kPCA with that. Okay, and again we'll just plot this out. All right, I think you immediately you'll be asking the question, say, why is it like that? This the kernel PCA trick, the kernel trick, whereby it actually pushes it into a different dimension, whereby originally what you have is a blob like this. Basically, they actually have two observations here. It actually now projected into one line. I guess you can still call this hyperbola, but it's not exactly a straight line, but it's a non-linear line, but it makes it easier for the logistic regression to actually segregate these two classes. So now you only have 1, 2, 3 errors instead of what you have here, which is 1, 2, 3, 4, 5, 6, 7, 8 errors here. I think this little simple illustration highlight the actual power of kernel PCA, especially when you are dealing with non-linear relationship. What I'd like you to do as an exercise is to maybe look at any non-linear relationship that you have seen or observed and try this out, and pause the video. I think Titanic has some of these examples as well, so I do encourage you to actually try it out, especially if I recall correctly, the passenger class, there's class 1 and class 3. Not all class 1 survive, not all class 3 survive. Some class 3 survive, some class 1 perish during the Titanic sinking. So that would be a good exercise to do. But first of all, plot it out, visualize it, and then see if you can actually apply this same trick to actually segregate non-linear relationship. With that, I'm going to end this lesson. This is really a short lesson to illustrate to you the power of kernel PCA. In the last lesson, we really touched on simple blobs that we make, 2 circles. In this example, we applied to the real-world data sets of the IRIS data sets. So when we return, I'm going to go into covering another machine learning algorithm that can be applied to a non-linear kind of relationship or non-linear underlying feature relationship, and that's called LDA. So I look forward to covering that topic in the next lesson. Thank you for watching.